Hello everyone, welcome to the discussions on the past year questions. This video we shall discuss about the further mathematics paper 2, further pure mathematics 2, May June 2023, paper 23. Let's take a look at the question number 1. Find the Maclaurin series of arcsine up to including in terms of x3. Okay, so what you need to do is first of all we let this as fx. Okay, we let the arcsine x as fx. Then you differentiate it. Just look from the formula booklet, MF19, and you get this. Okay, so in order to make your differentiation easier, usually I would suggest you to change it to become power of negative half. Then from here, you differentiate for the second time. Then you get a negative half, 1 minus x squared, power negative 3 over 2, negative 2x. We are applying chain rule over here, so you have this. Then after that, you differentiate for the third prime. You need to do until x power 3, so you need to differentiate until the third prime. So the third prime, we apply the product rule and the chain rule together, keep the left, differentiate the right. Plus, keep the right, differentiate the left. Okay, so we can simplify them. Over here, you can get this one as a 3 x squared, or 1 minus x squared, power negative 5 over 2, plus the 1 minus x squared, power of negative 3 over 2. Then after that, substitute 0 inside each and every one. Arcsine of 0 is a 0. Then this one, f prime of 0, you get a 1. Then f second prime of 0, you get a 0. Then as for the third prime, if you put 0 inside, the third prime, if you put 0 inside, you will get this as a 1 as well. Okay. So now after you have found all that, now your fx, you don't really have to copy down the formula. Okay, you can just write down. But over here, I just want to highlight again, the formula is f0 plus the f prime 0, x plus the f prime, f double prime 0, x squared over 2 factorial plus the f third prime of 0 of x cubed over 3 factorial plus a dot, dot, dot. Okay. Then if you put 0 inside, you'll get 0 plus 1x plus a 0 plus a 0 x squared over 2. It's a 0 lah. Okay. Then this one is a x cubed over 3 factorial plus a dot, dot, dot. So simplify further, you will get this one as a x cubed over 6. Okay, that will be your arcsine of x. Done. So this is the answer for the question number 1A. Then moving on, question number 1B is they want you to deduce an approximation. You see they use the word approximation. So the approximations over here, what you can say about this is actually this one is only approximately. Okay, over here I still write equal because I have a dot 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 means I have a infinite terms over here. I have infinite terms over here, so I still write equal. But if you want to write approximation, then you can just say that this is approximate without the equal sign, without the dot 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 sign. Okay, so now integrate this. Okay, it's the same as arcsine of u 1 over 5 to 0. Okay, 1 over 5 to 0. So this one will be arcsine of 1 over 5 minus the arcsine of 0. Okay. So this one is a 0. This one is a 0. Then arcsine of 1 over 5, this one we need calculator. So just put 1 over 5 plus the 1 over 5 cube over 6 minus a 0. So just use calculator. Divide 6 plus 0.2. Change it to fractions. They want in fraction form, right? So it's 151 over 750. So that will be the answer for the number 1B. Okay, this is the answer for number 1B. Okay, so now we move to the question number 2. The variable x and y are related by differential equations of this, and find the general solutions of x in terms of d. So what you need to do at first is, first of all, we take this one out, take the left-hand side part out, okay, let it equal to 0. Then we make it become auxiliary equations, short form AE, 6m squared plus 5m plus 1 equal to 0. Factorize it. This one can be factorized. So you get the m is equal to negative half and negative 1 over 3. Okay, negative 1 over 3 and negative half. So my contemporary solutions will be, my complementary solution, complementary solution will be YC equals to the AE power negative 1 over 3D plus the BE power negative 1 over 2D. Okay, so this is the XC. Then now for the particular integrals, we just let our XP, this is a quadratic, so our XP will be also in quadratic. So your XP prime 280 plus B, XP double prime will be 2A. Just like that. Then just replace this inside these whole equations. That means you will get 6xp double prime plus the 5xp prime plus the xp is equal to the t square plus 10t plus 13. So you have a 6 times 2a, you get 12a plus the 5 multiplied by 2at plus b plus the at square plus the pt plus c equals to the t square plus 10t plus 13. So we just need to spend some time to simplify them. At square plus the 10a plus pt plus the 12a plus the 5b plus c is equal to the t square plus 10t plus 13. So by comparison, A is equal to 1, our B is equals to 10a plus b, to be more precise. 10a plus b is a 10. So your b is a 0. Okay. Then 12a plus the 5b plus c is equal to 13. So you have 12 plus 0 plus c equal to 13. Therefore, I have c equal to 1. That means my particular integrals for xp will be t squared plus 1. Okay. That means my final solution, my general solution will be x equal to xc plus xp. Usually we put xc in front, xp behind. Then this will be ae power negative 1 over 3t plus the be power negative 1 over 2t plus the t square plus 1. Okay, so this is what we have for the answer for part A. Done. This is the general solutions because you have A and B remains as unknown. Okay, so now we need to go for the part B. State an approximation solution for large positive value of t. Okay, so when the t goes to infinity, the meaning for this one is the t is approaching to infinity. So what will be x approaching to or x equal to? So over here is that we know that the x we know that when the t approaching to infinity, the e power of negative 1 over 2t or 1 over 3t is equal to 0, approaching to 0. Then this one also approaching to 0. So therefore, your x is equals to the t squared plus 1. Okay. Now, to highlight to you that the mark scheme, they only accept equal. That means if you write x approaching to the t squared plus 1, they were not going to accept it. They're not going to accept it. Okay. So this one is something similar to the oblique asymptote. If you still remember our A2, our AS syllabus, chapter 2, the oblique asymptote, the idea is the same. When they are approaching to infinity, you just say that your oblique asymptote is equal to a particular function. But we will not say that it's approaching to. So this one, the answer is x equal to the t square plus 1. That will be the answer. Okay. Okay. So now, question number 3, complex number questions. So this question, they want you to use a binomial expansion to expand these two. And then after that, use the de Moivre theorem to show this. Okay. So actually, when you see these kind of questions, you need to know that we need to mention that if the z is equal to the cos theta plus I sine theta, then you need to know the rules that this one it will become 2 cos theta. Okay. Then the z minus 1 over z will become 2i sine theta. And in general, when you have this, you have a 2 cos n theta. And in general, if you have a z power n minus a z 1 over z power n, you get 2i sine n theta. So these are the things you need to know first. You need to list down first before you start solving these questions. So now we can start to expand this expression. You get z power 4 plus the 4z squared plus the 6 plus the 4 over the z squared plus the 1 over z power 4. So from here, you know that this, just by using this result, you get 2 cos theta power of 4. Then this one, you rearrange them, group them together like this. Okay. Then this one will become 2 cos 4 theta plus the 8 cos 2 theta plus the 6. Okay, so this is what we have. Then, of course, your left-hand side, you still need to continue to expand them. You get this. This one is a 16. 2 power 4 is a 16. Then you just need to leave the answer in terms of cos power 4. Then you get this one as a 1 over 8. I think no need lah, no need. Because later we can cancel it off. So no need to leave it like that. Okay, so that will be my first equations. Then similarly, my z minus 1 over z power 4 will be z power 4 plus the 4z squared plus the 6. Or this one is, there will be a negative here. Because this one, there's a minus here. So the negative and positive will go alternatively. Okay. Alternately, 4 over the z squared plus the 1 over z power 4. Then this one, you rearrange them, you get this. Okay. Then after that, this one, it will be 2i sine theta to the power 4. So 2 power 4, you have 16. I power 4, you get a 1. Sine power 4, you get sine power 4. This one is a plus, it's still a plus. So this one will be 2 cos 4 theta minus the 8 cos 2 theta plus 6. Okay, so that is equation 1 and 2. In order to get cotangent power 4, you just need to take equation 1 divided by equation number 2. You get 16 cos power 4 theta divided by 16 sine power 4 theta is equal to the 2 cos 4 theta plus the 8 cos 2 theta plus 6 divided by 2 cos 4 theta plus minus 8 cos 2 theta plus 6. So this is what we're supposed to have. Then after that, simplify them. You can cancel this. Then cotangent to the power 4 theta is equal to the cos 4 theta plus the 4 cos 2 theta plus 3 divided by the cos 4 theta minus a 4 cos 2 theta plus a 3. That will be the answer for the cos power 4 theta. You can just mention that therefore A is a 4, B is a 3. Okay, so this will be the answer for this question number 3. Done. Okay, now we take a look at the question number 4. The curve C has the equations 4y cubed plus the x plus y power 6 equal to 109. Show that at this point on C, the dy dx is equal to 1 over 17. Okay, so for this question is actually just do the implicit differentiations. 4y cubed differentiate, you get 12y squared dy dx. Over here, the dy dx, I just use a y prime to represent it. Then for the second term, I just use the chain rule. So power 5 and 1 plus the y prime equal to 0. Okay, so I do not plan to simplify them. I just leave it like this and then just straight away substitute this point at the point of negative 4, 3. So change your y to become 3. Your y prime is a dy dx and your x is a negative 4 plus 3 power 5, 1 plus the y prime equal to 0. Okay, so this one you can just expand them. You get this one as the 108 y prime plus the 6 y prime equals to this is a negative. This is a negative minus a 6 minus a 6y prime. So you get a 102 y prime is equal to 6. So your y prime is a 6 divided by 102. Press the calculator and you can get the answer as 1 over 17 shown. Okay, so this is how you show it. Okay, this is how you show it for the part A. Then now we move on to the part B. Part B, for these questions, we want to find a second derivative, d square y ds square at the point negative 4, 3. Okay, so in order to find the second order of the derivative, we need to just copy this result. Okay, I need to copy this result. From here, I do the implicit differentiations again. So let me just copy down 12y square y prime plus the 6 of x plus y to the power of 5, 1 plus y prime equal to 0. So from here, I differentiate one more time. So I need to use the chain rule, keep the left, differentiate the right. Okay, keep the left, differentiate the right, plus keep the right, differentiate the left. Okay, then second term, 30 x plus y to the power of 4, 1 plus the y prime square plus the 6 of x plus y to the power 5 of y double prime equal to 0. Okay, So I still don't plan to simplify them. I just straight away just write at this point, my y prime or the dy dx is 1 over 17. So just need to substitute them inside here. You get a 3 square y double prime plus the 24 of the y and the y prime, you square it, plus the 30 negative 4 plus 3 of power 4 of 1 plus the 1 over 17 square plus the 6 of a negative 4 plus 3 power 3. Now, not power 3, power 5. Okay, so need to write carefully and clearly. Then your y double prime equal to 0. Okay, so for over here, we need to use a calculator. So you can see that this is a y double prime, this is the y double prime. I need to combine them together. Okay, so in order to combine them together, just use your calculator. You get 108 minus a 6. So it's a 102 y double prime plus the 24 times 3 divided by 17 square. 72 plus 289. Then this one is 1 plus the 1 over 17 squared, then multiply 30. 9720289. Okay, so your y double prime is plus the 72 divided by 289 divided by 102. Negative 96 over 289. Okay, so that will be your second derivative. Okay, so since the question give you second derivative as a d square y ds square, you just write it down like this. Okay, just write down like this. Same thing goes for the part A. Just now part A, I think I forgot to write down. So the part A, I write in terms of dy dx. In terms of y prime, so just write dy dx is equal to 1 over 7. Okay, so that is the answer for the question number 4. Okay, so now we move on. Okay, so now we look at the question number 5a. This one is hyperbolic function. Chapter 1, starting from the definitions of the cos x and sine, cos and sine in terms of exponential, prove that 2 cos square x is equals to the cos 2x plus 1. So for this, proving the identity, you can go from the left or go from the right. So over here, I think I will go from the left. 2 cos square x. We cannot apply the result directly. We just need to use the definition start from exponential function. So cos will be e power x plus the e power negative x over 2 squared. So if you square it, this one you get e power 2x plus the 2 plus e power negative 2x divided by 4. So from here, you can see that you have a e power 2x plus the e power negative 2x over 2 plus a 1. Okay, so this is one terms over here is actually a cos of 2x plus a 1. So this is your right hand side proven. Okay, done for the part A. Now we go for the part B. Find the solutions of the differential equations. So this differential equation is actually the first order. It's a first order differential equation. So we need to know how to get it done. So usually our first order differential equation, usually it will be either separable variables or the linear equations. So over here, this one is linear equation. Linear equation means I need to use integrating factor to get the answer. Okay, so first of all, let me write down 2 tanh x multiplied by y equal to 1. So in order to use the IF, integrating factor, you must make sure that this is the 1. So this is the 1 already. Then we just straight away write down our IF as e to the power of integrate 2 tanh x dx. So integrate 2 tanh x, if you refer to the formula booklet, you're supposed to get 2 ln of the sine x. Okay. So, but we need to understand that we have a formula, e power ln of whatever is equal to whatever. Okay. So by applying this result, I will get this one as the e power ln of sine square x. So this will be the sine square x. Okay, it will be a sine square x. Okay, that will be your IF. So for the, oh, sorry, I make a mistake. This is not tanh x integrate. You're supposed to get cos x. You're supposed to get cos x. Okay, my apologies. So this is supposed to be cos. This is supposed to be cos. Okay, then now I just multiply everyone. Just take these equations over here. Multiply everyone by the IF. Multiply everyone by the cos square x. So you get cos square x dy dx plus the 2y cos square x tanh x equal to cos square x. So this is the IF. Okay, so actually we know that if you have an IF already, then this left hand side, to integrate them, just take the IF multiplied by the y. So it will be IF multiplied by the y is the same as integrate cos to x, cos square x. So integrate cos square x, we need to refer back to the formula. So the formula will be, need to use a similar to the double angle formula in trigonometry. Just apply the Osborne rule, then you can get this cos 2x plus 1 over 2. Okay, then after that, I continue it over here. Split them, you will get this one as a 1 over 4 sine 2x plus the half x plus a c. Your left hand side will be remain as a y cos square x. Okay, it will remain as a y cos square x. Y cos square x. Okay, so now after this, we need to look for the c. We need to look for the c. Y cos square x. Okay. Yeah. Okay. So this is what we have. Haven't complete yet because the questions is requiring us to give the answer y in terms of fx. So, but before that, we need to find the c by using this initial value. When x equal to 0, y equal to 1. When x equal to 0, y is equal to 1. So you have a y cos square 0 is equal to the half sine 0 plus the 0 plus c. So your c, the y is a 1. C is a 1. Okay. So from here, you can see that your y cos square x equal to 1 over 4 sine 2x plus the half x plus 1. But we want y in terms of x, so this one had to divide. All of them need to divide. You have a sine 2x plus 2x plus the 4 divided by the 4 cos square x. That will be the answer. Okay, this will be the answer. So now move on. Okay, now we take a look at question number 6. The diagram shows a curve with the equations y equal to the 1 minus x squared, where the x is between 0 to 1, together with a set of n rectangles of the width 1 over n. So the width over 1 over n means that the width over here, each and every one is 1 over n. And you have total n of the rectangle, okay? Total n of the rectangle. But by considering the sum of the areas of these rectangles, sum of the rectangle show that the integrations here is less than the un, where the un look like this. Okay, so the un is less, the integration, these integrations of the function is actually the area. Okay, this is the area under the graph. Area under the graph. Okay, and we want to show that this area under the graph is the less than the area under the rectangle. Okay, the area under the rectangle. So what you need to do now is, at first, you just need to let this y become fx. Okay, so this is represent the height of the rectangle. Okay, the height of the rectangle. So what you can do here now is you just show that the 0 to 1, this area is actually less than the area of the rectangle. So the rectangle, that the area of rectangle, you must have the rectangle that is higher, the rectangle that is higher than the graph. Yeah. So like this, if you keep on doing that until the last one, okay, then it will be greater than the area under the graph. Okay, so the area of the first rectangle, it will be f0 multiply 1 over n. Then after that, f1 multiply 1 over n plus until you have f n minus 1 over n multiply 1 over n. So you can see that all of them can actually written as, you can factorize the 1 over n out. Okay, you can factorize the 1 over n out. And over here, you can make this become a series. R equals to the 0 until n minus 1 of f r over n. You can change into this form. Okay, let me write the series symbol, sigma symbol properly. Okay, so you can make it like this. Then we want the r to start from 1. Okay, over here the r start from 0. So we just need to split them up. 1 over n f0 plus the 1 over n until n minus 1, r equal to 1 of fr over n. Okay, we can write it like this. We can split them into this way. So to save space, I will straight away write the f r divide n, make it become 1 minus r divide n square. Okay, we can write it like this. Then f0, if you put 0 inside, you get 1 over n. Okay, then this one you also get 1 over n. Then what you have in the series, what you need to do is just to expand the series. So if you expand the series, you get 1 minus a 2r over n plus the r square over the n square. Okay, this is what you can do. Then after that, the 1 over n now has become a constant. So what you split them over here is actually, this one is the sum of this minus the 2 over n. This one actually not needed to be stated down. However, I just write it down for explanation purpose. Okay, so I split them, become 3 parts. So over here, the r is a variable, the n is an unknown. Okay, the r is a variable and the n is an unknown. So what you need to do now is just need to refer to the formula booklet on how to find the series. Okay, so we have the formula in the formula booklet, MF19. This one will be n minus 1. This one will be n minus 1, n over 2. Okay, I think I need more space. So this one, let me just erase so that I can have more space to write down the whole sentence here. So this one I write as a 1 over n plus 1 over n. This one is a n minus 1 minus a 2 over n of the n minus 1. Then n divide 2. Then plus the 1 over n square. This one is a n minus 1. N. So 2n minus 1 divided by 6. Okay. So what you need to do now is to expand them and factorize it out. So this one, it will be n minus 1 minus the n minus 1 plus this can simplify. Then you get n minus 1 to n minus 1 over the 6. Okay. So this is what you have. And you can see that this one can cancel off. Then here, it will be 6 plus the 2n squared minus the 3n plus 1 divided by 6. Oh, this is a 6n. My apologies. Okay, so this is a 6n, and this one will be a 6n. Then if you continue here, you can get 2n squared plus 3n plus 1 over 6. And after you factorize it, then you get 2n plus 1, n plus 1 over the 6. So in order to show that exactly the same as the answer given, so I just make it become 2n plus 1, n plus 1 over the 6n. So this is what we have shown. Oh, by the way, the question didn't require us to expand. We can just, didn't require us to factorize it. We can just leave it as it is. So this one, just leave it as it is. Then you will get this as a 2n squared plus 3n plus 1 over the 6n shown. Then similarly, for the part B, we want to find the lower bound. Okay, so this lower bound, that means this integrate, it will be greater. Greater than what? So this time you have to change your rectangle from the taller rectangle to become shorter rectangle. So need to make it like this. Rectangle number 1, rectangle number 2. Okay. So you have to do until the last one. Okay, the last one is this rectangle. Okay. So that means this one will be greater than f1 over n multiply 1 over n, f2 over n multiplied by 1 over n until the last one plus the f n over n multiply 1 over n. So this one can be written as r equal to 1 fr over n. We can write like this. Okay. Then fr over n, just replace it inside the function. Then you get this one as 1 minus the r over n square. And from the previous result, part A, we actually have expanded them. So I just expand it. Actually, you can just apply the result that we have earlier in order to solve the problem. Okay. So here, this is the n minus the 2 over n. I straight away apply the result. N plus 1 over n over 2. N plus the 1 over n square. So it's n plus 1, 2n plus 1 over 6. We make it like this. Let me squeeze everything inside here. So this one, it will be written as the 1 over n square of n plus 1, 2n plus 1 over 6. Okay. So this is what we have. Okay. Then after that, we simplify first. N minus 1. Then this n, we cancel it. You get plus 2n squared plus 3n plus 1 over the 6n squared. This one can cancel off. 6n, no n square. This is 6n because the n already cancelled, 6n only. So this one, it will be 1 over n, negative 6n plus the 2n squared plus 3n plus 1 over the 6n. So now if we join it together, we almost get the answer. So you get this one as the 2n squared minus the 3n plus 1 over the 6n squared. And you can actually factorize them, become 2n minus 1, n minus 1, and 6n squared. So that will be the answer for the part B, the lower bound. Okay, that will be the lower bound. Then move on. We have C. C, they want to find the limit of n approaching to infinity of un minus the ln. So based on the expression that we have, un is actually 2n squared plus the 3n plus 1 over 6n squared. So the lower bound will be 2n squared minus the 3n plus 1 over the 6n squared. Okay, then after that you minus it. If you minus it, then you will get this one as 6n over the 6n squared. At the end, you get this as 1 over n. So at the end, you will get 0. Okay, done. Just like that. So that will be the answer for the question number 6, part A, part B, and part C. Okay, so now we move on to the next question. Okay, now we take a look at question number 7. The integral in, where n is an integer, is defined by, given here, find the exact value of I negative 1, given your answer in the form of ln a, where a is an integer to be determined. So for this question, we just change our n to become negative 1. Okay, so then this I negative 1 will be these integrations 4 over 3 of 1 plus x squared to the power of negative half. Okay, so this actually is the same as the 1 over the square root of 1 plus x squared dx. So from here, you can just check the formula booklet MF19. This is actually arcsine of x from 0 to 4 over 3. So this will be arcsine of 4 over 3 minus the arcsine of 0. Arcsine of 0 is a 0. Arcsine of 4 over 3, just refer to the formula booklet again. For the inverse hyperbolic function, you can change it to become a ln. Then you get this. 16 over 9 plus 1. Simplify it further, you can get this as a ln 9 over 3. Ln 9 over 3 is a ln 3. So this is how you get the answer for the part A. Now we move to the part B. So B, they're asking you to consider the differentiations here. So from here, you can see that you have product rules. Keep the left, differentiate the right, and keep the right, differentiate the left. Okay. So differentiate this. X 1 plus x squared to the power of half n. So over here, keep the left, differentiate the right. This one, it will be half n minus 1. Then this one, it will be 2x plus keep the right, differentiate the left. Okay. Then over here, you can see that we simplify them. The 2 and the 2 can cancel. The x over here can join together. Then you can have something like this. N x squared 1 plus x squared n over 2 minus 1 plus the 1 plus x squared power of n over 2. Okay, so we want to show into this form. Okay, we want to show them into this form. So what you need to do now is, okay, the trick is you need to change this to become 1 plus x squared minus x minus 1. Okay, so the trick is you change this to become 1 plus x squared minus 1. Then this one, it will be 1 plus x squared n minus 2 over 2. Okay, you combine this together, become 1 fractions, you'll get n minus 2 over 2. Okay. Then the last term over here, just write it down as usual. So now this part and this part is considered as the same. If you expand them together, then you will get this. N 1 plus x squared power n over 2. Then minus the n of 1 plus x squared power of n minus 2 over 2 plus the 1 plus x squared power n over 2. So you can see that these two is the same term. You can join together, then you will get this. N plus 1, 1 plus x squared power n over 2 minus the n, 1 plus x squared n minus 2 over 2. Okay, so this is what we have. So this is the differentiations, but the in over here is representing integration. So what you need to do now is to go reversely. That means you want to integrate. So for the right hand side, for the right hand side over here, if you integrate the whole thing, then your right hand side will become in and in minus 2. Okay, so over here, let me just write down. The left hand side, after you integrate, the left hand side, after you integrate, you get back the same thing. You will get back this. The left hand side, after you integrate, the left hand side, you'll get this. From 0 to 4 over 3. Then your right hand side will be look like this. Okay, so this will be minus 2 over 2. So 0 to 4 over 3. 0 to 4 over 3. So for left-hand side, substitute the value 0 and 4 over 3 inside. So if you put 4 over 3, you will get this one as a 4 over 3. 1 plus the 16 over 9. N over 2 minus a 0 equals to the n plus 1 of in minus the n of in minus 2. So your in, leave it here. Your in minus 2, bring it to the other side. You will get this. Plus the 4 over 3 and 25 over 9 of n over 2. Okay, so you can see that because 25 over 9 is actually 5 over 3 square. Okay, and this one is a divide 2. So at the end, you can simplify them and it will become like this. 5 over 3 power of n. This is what you will get. So is this the form that the question wanted to show? Yes, correct. Okay, so shown. Okay, so this will be the way how to show the relationship. Okay, done. Now we move on to the part C. Okay, so the part C, the curve has the equations of y equal to x squared for the x between 0 to 2 over 3, including 0 and including 2 over 3. The arc length, they mentioned arc length of the curve is denoted by s. Use a substitution u equal to 2x, show that s is equal to half I1. After that, find the exact value of the s. So we need to know the formula for the arc length. Okay, so first of all, y equal to x squared, we need to find the dy dx. dy dx is a 2x. Okay. Then the formula for the arc length is actually 0 to 2 over 3. Square root of 1 plus the dy dx square dx. This is the formula for the arc length. So you can see that if you do it this way, you will get this one as a square root of 1 plus 4x squared dx. And then the question asking you to use this as a substitution in order to find the arc length. Okay, so we just let our u is equal to the 2x. So from here, you will get that du is equal to the 2 dx. Or you can say that the dx is equal to the half du. Then when the x is equal to 0, your u is equal to 0. When x is equal to 2 over 3, your u is equal to 4 over 3. So these are the things you need to prepare before you do the substitution. So by all this substitution, now you're ready to change this to become 0 to 4 over 3. This one will become 1 plus the u squared. This one will become half the u. So this will become half 0 to 4 over 3, 1 plus the u squared power of half du. Okay, so this is exactly the same as the half of I1. Okay, exactly the same as the half of the I1. Shown. Then after that, they want you to find the exact value. So from here, from the answer that I have over here, okay, then from part B, we have n is equals to 1. Okay, from part B, your n equal to 1. So you will get 2I1 is equals to the 1I negative 1. Okay, so you have a 2I1 is equals to the 1 of I negative 1 plus the 4 over 3 and and multiply by 5 over 3 power 1. Okay, so this is what you have. Okay, this is what you have. Then your I1 will be half of I negative 1 plus the 2 over 3 multiplied by 5 over 3. Okay. Then just use the I negative 1. I negative 1 just now we already have in part A. Part A we already have I negative 1 is ln 3. So this one will be half ln 3 plus the 10 over 9. So therefore, S is equal to the half I negative 1. So it will be 1 over 4 ln 3 plus the 5 over 9. Okay, so this will be the answer for the question number 7 part C. Okay, just like that, done. Now we take a look at question number 8. The matrix A is given as such, where A is a constant with A not equal to 0 and A not equal to 1. So these are the given condition. And part A, show that the equations of this has a unique solution and interpret these situations geometrically. Okay, so we need to show that this equation is unique, has a unique equation. So what you need to do now is to show the determinant not equal to 0 will do. Okay, so just start from here. Is a 1 minus A, 2 minus A, 2A plus 2, 0, negative 1. Okay, then after that, just do the determinant, find it. This is A minus 1, 6A, you have a 0, 2A plus 2, and you also have a 0. Okay, so at the end, you get this. Okay. So because of A not equal to 0 and A not equal to 1, therefore, A and A minus 1 cannot be 0. Okay, that means, therefore, the solution, the equations of this has a unique solution. Okay, and after that, they want you to interpret this situation geometrically. Okay, so these 3 planes form a unique point. Just like that. Okay, so the 3 of the planes after they intersect, they will intersect at a point. Just like that, done. Now we go for part B. Show that the eigenvalue of A out of the matrix A are A, 1 minus A, and negative 1. Okay, so this one, just take the matrix A minus the lambda of the I, and you get this. Two A plus 2, 0 minus 1 minus lambda. That is equal to 0. So we do it again. So basically, it's the same as just now. The rest of them will be 0 as well. Okay, so at the end, you will get A minus lambda, lambda minus 1, lambda plus 1, and lambda minus 1 plus A. Okay. So therefore, your lambda equal to A, your lambda equal to negative 1, and your lambda equal to 1 minus A. Shown. Okay, that is the answer for the part B. Quite straightforward over here at the moment, but later when we go for the part C, it will be quite complicated a little bit. So we want to find the matrix P and the diagonal of the matrix D. So to find P, we need to find the eigenvector for each of the eigenvalue. So we start from lambda equal to A. So when the lambda equal to A, just replace the lambda A inside here, here, and here. And you look for any two that is not repeated, okay, or not multiple of each other. Okay, just choose any two. Okay, so if you substitute lambda equal to A inside, you will get, if you put lambda equal to A inside, this one you will get 0, negative 6A, to A plus 2. Okay, and the second row will give you 0, 1 minus 2A, and 0. So we'll choose these two to find the eigenvector. Okay, we choose these two to find the eigenvector. So for this case, I just put ijk. So because the expressions over here contains the value A, so it will be quite troublesome to solve it. One minus a 2A and 0. So this one, if you use the just expand them, like the way that you do the determinant just now, so you get this one as a 2A minus 1I, 2A minus 1, oh, sorry. And for the J, you will get 0J and 0K. So you can factorize this one out. And this whole thing will get 100. Okay, so therefore your E1, this is I call lambda 1. Okay, so my E1, eigenvector number 1 will be 100. Then lambda 2, I choose lambda 2 to be a negative 1. Again, just repeat the process like just now. Replace the lambda equal to negative 1 inside the matrix that you have just now. Okay, matrix. Just replace the lambda negative 1 inside here again. Okay, just replace it inside. You get A minus 1. You get negative 6A to A plus 2. Then this one is the 0. So you get negative A and 0. So, oh, sorry, this one is a 2 minus A. Okay, then you find again, you find the eigenvector from here again. Okay. So over here, I just replace the lambda equals to the negative 1. So I get 2A minus 1. Oh, sorry. I get A plus 1. A. 2A plus 2. And then 0. 2 minus A and 0. So this one, the same time I expanded earlier for you. So I just copy down my answer. You can actually try to expand it yourself. Okay. So this one is a minus A minus a 2A, multiplied by 2A plus 2. Okay. Then 0I, 0J, sorry. Then for the K, it will be A plus 1, 2 minus A. Okay. So you can see that you can factorize the A plus 1 and 2 minus A out. But inside here, you will get 2, 0, and 1. Okay. Negative 2. Okay, to be more precise. minus A. There's a minus here. Okay, I forgot. So there's a minus here. So you get negative 202, negative 201. So this will be your eigenvalue number 2. This will be eigenvalue number 2. And for eigenvalue number 3, lambda 3 is equals to 1 minus A. So if you do it again, so this the last one over here is kind of troublesome. So you get 2A minus 1, 0, negative 6A, 2A plus 2. And this one is 2 minus A and A minus 2. So for this case, you have to substitute the lambda equal to 1 minus A inside here. You get this as a 2A minus 1, negative 6A, 2A plus 2. And if you put this inside the second one, okay, if you put it inside the second one, you get 0, 0, 0, not suitable to use it. So therefore, you can only choose the first and the third row of the value. Okay, so this one, if you put it inside, you will get 2 minus A. That's 2. Need to choose these two. You need to choose these two to find the eigenvector. Okay, so we will choose the first row and the third row to find the eigenvector. The second row cannot, because the second row, all the elements will be 0. So we just choose the first and the second and third row. So this one, a bit troublesome, huh? Okay. So if you expand them at the end, you will get this as a negative 4A squared plus the 10A minus 4I. So I expand for you, but you try to expand it yourself. Practice yourself. Okay. Then K will be a negative 2A squared plus the 5A minus the 2. Okay. So it's even you want to find see that they have actually common factor also a bit kind of difficult. Okay? But actually the common factor will be a 2A squared minus 5A minus 2. Okay. So I take the common factor out. The common factor, I take it out as a negative 2A squared plus the 5A minus a 2. Then inside here, the whole thing that I have inside here will be a 211. Okay. So therefore, my E3 will be 211. Okay. So since we have found this answer for part C, okay. Oh, haven't done yet. Part C haven't finished yet. Not enough place already. Okay. So this is the answer. This is the only what at the moment I can only find the B. B is a E1 100, and then E2 negative 201, and then E3 211. That is a matrix B. Then for the matrix D, so we need to know that A power 4 is equals to the B and then D B inverse. They give you this, okay? They give you this relationship. Okay. So that means the D is actually the diagonal matrix multiply a power of 4. Okay. The D is actually the diagonal matrix power of 4. So what you need to do is just to take the diagonal matrix power of 4. So the diagonal matrix just now my lambda 1 is 8. My lambda 2 is the negative 1. My lambda 3 is 1 minus A. So at the end, your D will be A power 4. Then 0, 0, 1 minus A power 4. That will be a D. Okay. So this will be on D, just like that. Done. Then after that, part D, use the characteristic equations of A to find the A power 4 in terms of A, matrix A, and the constant A. Okay. So over here, just use the characteristic equation. This is the characteristic equation that we have just now. So from here, we just expand them. Okay, just use this, expand them. So over here, I just take down, copy down the result. Just now I factorize the negative out already. So this one, it will become, oh, maybe never mind. I just put 1 minus A minus lambda. Okay, so over here, if you expand them, just I have to expand them carefully. Okay, so I take these two to expand first. Easier, because the middle one, it has a 3 terms. So I get a negative A minus a lambda plus a 1 plus a lambda plus a lambda square. Then 1 minus a minus lambda equal to 0. And then if we expand further, okay, so to save time, I expand directly. I give you the final result that I have. We want to make the highest power positive. So at the end, you're supposed to get something like that. Okay, if you expand them carefully. Okay, so this will be the result after you expand them. Then from the Hamilton theorem, so you get a cube minus this, a minus this, I equal to the 0. Okay, then your A3 will be equal to this. And you multiply by A, you get A power 4 equal to this. A square plus A. Done. That will be the answer for this question D. Okay, and that will be the last part for this paper. Okay, so I stop the video here.